Picture this, an AT-14 Cornet anti-tank missile, a supersonic predator designed to shred through over a meter of solid steel, screaming across the desert. Its target? An Israeli Merkava Mark IV. The distance is closing at hundreds of meters per second. In any other era of warfare, this is the end of the story. A massive explosion, a plume of black smoke, and another multi-million-dollar machine turned into a burning scrap heap. The infantry nearby braces for the shockwave. The missile is inches away. It's inevitable. But then, the laws of physics seem to break. In a fraction of a heartbeat, just before the tip of that warhead can kiss the tank's hull, a violent counterblast erupts from the side of the vehicle. The missile doesn't just miss, it's disintegrated in mid-air. It blooms into a ball of orange fire and twisted shrapnel, far enough away that the tank doesn't even have a scratch on its desert-tan paint. The crew inside, they might not have even felt a vibration. This is the paradox of the modern battlefield. We are watching a relentless, high-velocity attack meet a literal invisible wall. How is it possible for a 60-ton behemoth of iron and lead to possess reflexes that are, quite literally, faster than a speeding bullet? How can a machine this massive react to a threat it can't even see with the naked eye? For years, the experts said the age of the tank was over. They called them rolling coffins in the face of cheap, mass-produced insurgent tactics and shoulder-fired rockets. But what you just witnessed is the definitive end of that era. The era where the tank was just a big, slow target is officially dead. This is the birth of the immortal machine. And today, we are going to dive deep into the secret technology that makes it possible. To understand why this matters, we have to look at the brutal reality of modern warfare. For nearly a century, the tank was the undisputed king of the battlefield. If you had the thickest steel and the biggest gun, you won. It was a simple game of power. But in the last 2 decades, that crown didn't just slip, it shattered. Look at the footage coming out of modern conflict zones today. You don't see massive tank-on-tank battles across open plains anymore. Instead, you see these 60-ton, multi-million-dollar machines rolling into tight concrete labyrinths, cities, and that's where the nightmare begins. Hidden in a third-story window or behind a pile of rusted cars is a single insurgent with a weapon that costs less than a used laptop, a shoulder-fired RPG-7 or a guided missile like the Cornet. The problem is that traditional armor has reached its physical limit. You can only add so much steel before the tank becomes too heavy to cross a bridge or move through a street. And the insurgents? They aren't aiming for the thick front armor. They are aiming for the roof, the rear, or the tracks. Suddenly, that invincible fortress becomes a steel trap for the 4 humans inside. This isn't just a tactical shift, it's a technological humiliation. For a long time, the only solution was to pray the enemy missed. But hope is not a defensive strategy. That's when the engineers stopped looking at how to absorb a hit and started looking at how to prevent it entirely. They realized that in the age of precision missiles, the best armor isn't steel, it's information. This led to the birth of the Trophy Active Protection System, or APS. It's not just an upgrade, it's a complete reimagining of what a tank is. At the heart of this system is what the crews call the divine eye. If you look closely at a Merkava Mark IV or an American M1A2 Abrams equipped with Trophy, you'll see 4 flat, rectangular plates mounted on the turret. These are active electronically scanned array radars, or AESA, built by ELTA. Each plate covers a 90-degree arc, and together, they create a full 360-degree protective bubble around the vehicle. These radars are constantly pinging the environment, thousands of times a second. But imagine the chaos they have to filter through. In a dense urban battle, there's smoke, falling debris, birds flying, and thousands of rounds of small arms fire zipping through the air. For an ordinary radar, this would be total white noise. It would be blinded. But the Trophy's brain is designed to ignore the junk. It uses advanced Doppler algorithms to differentiate between a rock thrown by a protester and a specialized anti-tank round traveling at Mach 1. It calculates the object's mass, its velocity, and most importantly, its trajectory. If the computer determines that the projectile will miss the tank by even a few inches, it does nothing. It stays silent, but if the math shows a direct hit is incoming, the system wakes up instantly. Think about that contrast for a second. On one side, you have the low-tech threat, a simple explosive-shaped charge inside a metal tube fired by a person hiding in an alleyway. On the other side, you have a high-tech guardian angel that operates on a timescale humans can't even perceive. This system has to be perfect every single time. It doesn't get a second chance.
But seeing the threat is only the first half of the miracle. Once the radar locks on,
and the computer confirms the kill zone, the system has to make a life or death decision. It has to coordinate a physical response to an invisible predator, and it has to do it while the tank is moving, while the turret is rotating, and while the wind is blowing. You might wonder, how exactly does a machine go from a blip on a radar screen to a physical interception in less time than it takes to blink? How does it fire a countermeasure that destroys the enemy but leaves the infantry standing right next to the tank completely unharmed? To understand that, We have to go inside the brain of the machine and look at the dead-eye millisecond, the absolute limit where physics and computation collide. So let's go inside those dead-eye milliseconds. To a human, a second is a brief moment. To the trophy system, a second is an eternity divided into 1,000 distinct chapters. To understand how this works, you have to realize that the system isn't just reacting, it's solving a complex physics equation in real time while being shot at. It all starts with the detection phase. Remember those 4 AESA radar plates we talked about? They are searching the air at a rate that would make a supercomputer sweat. The moment a projectile enters the radar's bubble, the system doesn't just see a dot, it sees a signature. Within less than 5 milliseconds, the internal processor begins the classification phase. This is the brain at work. It uses the Doppler shift, the way waves change frequency as an object moves to determine exactly what is flying toward the tank. Is it a 7.62mm bullet from an AK-47? If so, the system ignores it. Is it a bird? Is it a piece of flying concrete from a nearby explosion? The trophy is smart enough to know that reacting to the wrong thing is just as dangerous as not reacting at all. But if that signature matches the profile of an anti-tank guided missile or a rocket-propelled grenade, the system shifts into overdrive. Now we enter the calculation phase. This is where the math gets insane. The computer isn't just looking at where the missile is, it's predicting where it will be in the next 50 milliseconds. It calculates the azimuth, the elevation, the velocity, and the exact estimated point of impact on the tank's hull. If the math shows that the missile will strike the armor, the system designates a hard kill intercept point, specific coordinate in three-dimensional space, usually just a few meters away from the vehicle. To put this speed into perspective, think about a human blink. A typical blink takes about 300 milliseconds. In that same amount of time, the trophy system could have detected a threat, classified it, calculated the solution, launched a countermeasure, destroyed the threat, and already started looking for the next one. 6 times over, by the time your eyelid has finished moving down and back up, the battle is already over. Now, let's look at the secret sauce, the part that actually does the killing. This is the interception phase, and it uses something called MEFP, or multiple explosively formed penetrators. In the original Insurgent script, we saw how they repurposed sugar and fertilizer to make crude explosions. The trophy system is the peak of that evolution. Inside the countermeasure launcher is a precisely engineered matrix of small metal pellets. When the system fires, it doesn't just create a random blast. A small, controlled explosion behind a metal plate reshapes those pellets into a high-velocity shotgun pattern of molten metal. These tiny penetrators are launched with surgical precision. They don't just hit the missile. They strike the specific part of the incoming warhead required to neutralize it before it can detonate. But here's the real aha moment. Why doesn't this explosion kill the friendly soldiers standing right next to the tank? That was the biggest hurdle in active protection for decades. The genius of the MEFP is its extremely narrow engagement zone. The blast is so focused, and the pellets are so small that they lose their energy almost immediately after destroying the target. This creates a safe zone for infantry, allowing tanks and foot soldiers to work together in tight urban alleys without the tank accidentally killing its own support team. But the protection isn't just a single wall. Just like the underground metro we analyzed earlier with its 8 distinct levels, the trophy system operates as a multi-layered fortress. At level 1, you have the AESA early warning. This is the constant 360-degree scan that never sleeps, even if the crew is exhausted or blinded by smoke. At level 2, we have the combat management system. This is the digital map inside the tank. The moment the radar pings a threat, it doesn't just stay in the trophy system, it's fed into the tank's main computer, marking the enemy's exact GPS coordinates on the commander's screen. At level 3, you have the flexible launcher. These are the physical units on the sides of the turret that can rotate and tilt in an instant, ensuring that no matter where the missile comes from, whether it's a top attack from a roof or a low shot from an alley, the shotgun is already pointed at it. And finally, at level 4, you have the failsafe, the reactive armor. If, by some miracle, a threat is too close or the system is overwhelmed, the physical armor and explosive tiles are still there as the final line of defense. It is a vertical stack of security that makes the vehicle nearly impossible to hit. But here is the ultimate twist, the part that truly changes the face of war. For decades, tank under attack was like a blind man being pelted with stones. He knew he was being hit, but he didn't know from where. Trophy changes that. The system is so precise that the moment it intercepts a missile, it calculates the exact origin of the launch. Within a fraction of a second after the intercept, the computer can automatically slave the tank's main 120mm gun or the remote weapon station directly to the source of the fire. The tank commander doesn't have to go looking for the guy who shot at him. He just presses a button, and the turret has already rotated to the exact window or trench where the missile originated. Defense doesn't just protect the tank, it instantly turns into a lethal counterstrike. The guy in the alleyway thought he was the hunter. He didn't realize that the moment he pulled the trigger, he became the target. This shift from passive armor to active, intelligent defense is why we are seeing a total transformation in how armored units operate. The tank is no longer just a shield, it's a sentient predator. But as impressive as this is, the game of cat and mouse never ends. If the tank is now immortal, what happens when the enemy stops firing one missile and starts firing 10? Or when the threat doesn't come from an alleyway, but from a swarm of drones in the sky? The millisecond of life and death are getting even more crowded, and the future of the battlefield is moving faster than we ever imagined. What we are witnessing with the trophy system isn't just a clever upgrade or a new piece of gear. It is a fundamental revolution in how we define survival on the modern battlefield. By turning a 60-ton machine from a passive target into an active sentient predator, Trophy has effectively closed the door on a century of anti-tank doctrine. It has bridged the gap between raw, physical power and the split-second world of digital computation. But as impressive as this technology is, we have to remember one thing. The arms race never sleeps. History shows us that as soon as someone builds a better wall, someone else starts designing a bigger hammer. The game of cat and mouse is already shifting into its next, even more dangerous phase. If the guided missile is no longer the guaranteed tank killer it once was, what is the next weapon to claim the throne? Are we moving toward massive swarms of AI-driven drones that can overwhelm these radars through sheer numbers? Or perhaps high-energy lasers that strike at the speed of light, leaving no time for a mechanical response? The immortal tank has bought itself a new lease on life, but its enemies are already evolving in the shadows. In our very next video, we are going to dive into the ultimate counter-threat, the kamikaze drone. We'll see how these cheap plastic predators are being specifically designed to find and exploit the tiny hidden weaknesses in systems like Trophy. You won't want to miss that breakdown. If you found this deep dive into the Divine Eye fascinating, make sure to hit that subscribe button. We are mucking through the most complex military tech on the planet to bring you the truth behind the headlines. Stay subscribed so you never miss a beat. The future of warfare is moving faster than we can blink, and we're here to make sure you stay one step ahead.